Okay, this is a snapshot sample proportion problems. This is out of section 6.3 of the book, so you should at least read over that particular section in the book. Anyway, you should already be familiar with what a proportion or a ratio means. That is basically a fundamental concept. I'll just remind you, proportion, ratios, fractions, percentages, in a way, they're all the same. 35% of the people surveyed prefer Coke is the same thing as saying 35 out of 100 people prefer Coke. The same thing as 35 divided by 100, or 7 divided by 20 prefer Coke. So again, you are responsible for reviewing this concept if you do not understand proportions and ratios. And we will basically be working with the decimal version, right? 0.35 would be what we'd be working with if we were actually looking at this particular topic, preferring Coke. Now, suppose you have a population and we let X represent the proportion of the population that has a certain characteristic. Okay, that is before, remember we looked at binomial, we said how many people preferred Coke. 3 preferred Coke, 4 preferred Coke. Now we're looking at a proportion, a percentage of the population. 2 out of 5 are red, 17% drink water, 9% are defective. We're not asking how many, we are asking what proportion. So don't get this confused with a binomial, okay, which is counting how many there are. So if we let P represent the proportion of the population with that characteristic, then P is equal to the population proportion. So we let P represent a proportion. A random sample of size N is taken, and we let X represent the number in the sample having that characteristic. Okay, so X in a way is, again, like binomial, but we're not talking really about how many. We are going to actually be looking at the sample proportion. And this is defined to be P hat equal to X divided by N. So again, in a binomial problem, we would be looking at X. In a proportion problem, we are looking at P hat, which is the proportion of the population, the percentage, the fraction stated here. So our population proportion is represented by P. The sample proportion is represented by P hat. Just like X bar represents a population of sample means, the central limit theorem, P hat can be thought of as representing a population of sample proportions, and the following holds. So that's supposed to be 2 L's, right? P hat is approximately normally distributed, that's important. And the mean of P hat is the population proportion. So the mean is the population proportion. Just like, remember, with X bar, the mean was mu, the population, right? The standard deviation of P hat, given right here, okay, is the square root of P times 1 minus P over N. Remember, for X bar, sigma of X bar was equal to what? Sigma divided by the square root of N. So if we're working with the proportion, we're working with the population proportion for the mean, and we are representing the standard deviation of the sample proportion with the square root of P times 1 minus P over N. There are conditions that have to be met, but we're going to be focused on this piece here right now. That is sample proportion, normally distributed, what the mean is and what the standard deviation is, because this gets us to the table. Okay, you should look over the problem, get a feel for it. And the first thing you need to do is identify the problem. This is a probability question about a proportion of a sample. 30% of the sample win a big prize, right? So I am looking for the probability that p hat is greater than or equal to 0.3. This is a proportion probability question, right? I need to get to the table. The way I get to the table is by knowing what the mean is. Let me give my pen a little bit more space. I don't like the purple. Anyway, the mean is equal to the population proportion. The population of tickets that are winners is 0.25. The sample or the standard deviation for p hat is a formula. The square root of p times 1 minus p over n. You figure it out. It's going to equal to 0.0518. Okay, plug in p, 1 minus p, n is equal to 70. Now we're ready to get to the table. We get to the table by subtracting the mean, dividing by the standard deviation. You do the math, right? You're going to get z is greater than or equal to 0.97. That is 1 minus what the table tells us, right? The table tells us 0.8340. We do the math, 0.1660. So about 17% probability that at least 30% of the people or the sample of size 70 win a big prize. So quickly review it. A probability question about a proportion. Okay? Again, we need to get to the table by knowing what the mean is. About the previous page, the mean is the population mean, which is the proportion for the population, 25%. Sigma is a formula. Square root of p times 1 minus p over n. N is equal to 70. Do the math. We're ready to get to the table. There's the get to the table formula, right? Then we look at what particular case when we're at the table, right? This is opposite of what the table was telling me. And there's my answer. Okay, read the problem, look it over, and I'm going to say a few things about the type of problem. What is the probability the sample proportion will be between 70 and 85%? I am asking this question. The probability that the sample proportion is between 70 and 85%, right? So it's a question on the probability associated with a sample proportion. We need to get to the table. I need to get to the table. I need to know what the population proportion is, right? The population proportion, 8 out of 10. 8 out of 10 students attend graduation. So 0.8. Sigma is the square root of p times 1 minus p divided by n. P is the population proportion, 0.8. Plug those numbers into the formula. N is equal to 50. So n is going to be 50. You do the math. When you do the math, you should get 0.0566. Now that I have the mean and the standard deviation, the typical formula that gets me to the table, subtract the mean, divide by the standard deviation, I'm now working with Z. Subtract the mean divided by the standard deviation, right? That's how I get to the table. You do the math. You're looking for Z between a negative 1.77 and a 0.88 when you do the math up here. Well, that is the third case of using the table. You're between the two numbers, so it's the higher percentage minus the smaller percentage. So look up those two numbers in the table. They are the percentages. When you do the math, you get 77.22, about a 77% chance that of the 50 students, between 70 and 85% of them will be non-science majors. Now notice most of these problems are very similar. They're all proportion probability questions. The difference between them basically is how the percentage of the population is expressed. 5 out of 10, 30%, the ratio maybe. So again, the main thing is to identify the problem in general. And here's the question. It's worded a little bit differently. If a sample of 75 voters was polled, would it be unusual if less than 40% of them had voted Democratic? So we're talking about a percentage of a sample. So you know this has to involve p hat. We should look up the probability that p hat is less than 0.4. Since we're talking about p hat, the mean is equal to the population mean, 53%. The standard deviation is that typical formula. I'm not going to write it down here. I'll just give you the numbers because you should be working this out yourself and not just looking at the video. Okay? Anyway, again, proportion, problem, probability, the mean, population, the standard deviation, the formula comes out to be this. I'm ready to get to the table. I get to the table by, again, subtracting the mean, the typical thing. You should have that memorized by now, right? Divided by the standard deviation of what I am talking about. Okay, let me fix that. Okay. All right, do the math. When you do the math, you're going to get this is equal to a negative 39. This is case 1 in the table. If you look at case 1 in the table, it tells you anything below a very, very negative number is about 0.0001. There's about no chance this should happen. Okay, so I would say yes, it is unusual for this to happen. It can happen, but it's highly unlikely to happen, so I guess we should use the word unusual, right? Okay, moving on. Here's our final example here. You read it over. Let's see what we have. We want the probability at most 5% of the gadgets are defective. We took a sample. We purchased 20 gadgets. 5% of them, at most 5%, are defective. That is the probability that our sample proportion is no greater than 0.05. Okay? Once again, we're talking sample proportion. Our mean is 1 divided by 15. Our standard deviation is the formula. If you work out the formula, you will find out that sigma is about equal to, if I remember, 0.0558. Okay, now you can approximate mu by, well, 0.15. 1 over 15 is about equal to 0.0667. Okay, if you want to work with fractions, go ahead. Well, at least in statistics, you can work with a decimal number. Just make sure you keep enough places. Okay, so anyway, the mean for the sample proportion is the population proportion. The standard deviation is that formula. I did the math, you do the math. Now we're ready for the table. The probability that z is less than or equal to 0.05 minus the mean 0.0667 over the standard deviation 0.558. When I clean this up, I get z less than or equal to negative 0.3. This is the table, so I'll look up negative 0.3 in the table. Let me fix my writing there. 0.3821. There's the answer. Okay? The next problem, B. Determine the probability that most one gadget is defective. Whoa. What's going on here? Think about it. We're no longer talking about a probability of a percentage. We're talking a probability that most one. We're counting now. You know what? This is binomial. Okay? Toss that in on you because you have to be able to identify a problem first. Okay? This problem is a binomial problem. At most one gadget. Okay? At most one gadget is 0 or 1. So you can use that formula twice. I don't think that's bad, but I'm going to walk you through the normal approximation just to do it. Okay? So again, be careful. All of a sudden I went from a percentage to counting. So we're looking for the probability that x is less than or equal to 1. Well, the first step in a normal approximation of a binomial is to either add a half or subtract a half. Well, in this case, I'm going to be adding a half. You justify that. Okay? I need to get to the table. The mean is now n times p. Show yourself that is equal to 1.33. The standard deviation is the square root of npq. Show yourself that is 1.1158. I'm ready for the table. The probability that z is less than or equal to 1.5 minus 1.33 divided by 1.1158. Do your math. When you do your math, that is 0.15. And you look that up in the table, and it's exactly what it is because it is case number 1. About 56%. There's a 56% that at most one gadget is defective. Okay? So be careful because again, here I was talking about the probability of a percentage, a proportion. Here, probability of at most one gadget, 0 or 1. I'm counting the number of defective. Binomial. You could have used the formula 2 times because x less than or equal to 1 would be 0 or 1. Here I demonstrated a normal approximation. And there's my answer. All right, so good luck. Hope I'll go over a couple of these in class with you. But as you can see, it's really just another formula. And again, identification of the problem. But I need to get to the table.